Alright, in the case of super elevation not known, it's suggested that the value assumed with the 7 millimeters up is a 1 degree curve with 115 millimeters up, 115 millimeters for curves above number 1 degree. No extra clearance is required with leaning on the outside of the curve. Leaning due to the curved vehicle position, super elevated vehicle on the position of the level of track, the effect of leaning due to the super elevation. Effects on the sway vehicles on account of the unbalanced central figure of the car, but the deficient can't access the vehicles for tended with experienced additional sway. The extra clearance required to on inside of the curve due to the sway is taken on 1/4 of the clearance necessary to do the lean. On the summarizing the total clearance in minimum millimeters required to curve is as follows. Extra clearance inside the curve is equal to overthrow plus lean plus sway, or EC1 divided by equals C squared over R plus 8 over 8R plus EH over G plus 1/4 plus times EH over G. Extra clearance outside of the curve and throw where the C is the center of the distance of between the bogies of 1470-85 millimeters of baggy routes with 13,715 millimeters meter gauge. The radius of the curve minimum millimeters length is of the boogie, which is 24,340 millimeters of the broad gauge route, 19,510 millimeters of the meter gauge, and super elevation in millimeters of height of the vehicle is which 3,350 millimeters from the broad gauge tracks, 3,200 millimeters for meter gauge, and G is for gauge, whereas 1,676 for the broad gauge, 1,000 millimeters for the meter gauge track. The imperial formula normally adopted the field to determine an extra clearance due to the curvature effect as follows. Overthrow the millimeters 27,330 times the radius. Broad gauge 23,516 times the radius. Meter gauge. End throw millimeter 29,600 divided by radius. And meter gauge 24,063 gauge. Empirical formula based on the broad gauge meter gauge boogie length, the value of the R and value of the R in the metrics. 1371 extra clearance required for the various situations. The section discussed the extra clearance required for the different situation regarding the track and platform between adjacent curved tracks. In this case, the lean will not be taken into consideration. Both tracks will have almost super elevation. Extra clearance required in this case will be below some of the clearance required for the inside outside of the curve as follows. EC1 minus 1 lean equals EC2. Overthrow plus sway equals plus or minus end throw. Whereas the E is super elevation in millimeters, H is the height of the vehicle, and 3.35 millimeters broad gauge, 3.2 millimeters meter gauge, and gauge is the G is gauge. For adjacent tracks with structures in below, where there's structure between the two adjacent tracks, each of the track is treated independently. Extra clearance are provided with considering each track with respect to the structure. Platforms. In the case of the platforms, it is observed the provision extra clearance of the curve discussed as maybe the excessive gap between the footboard and the platform. Therefore, stipulated the next platform's extra clearance between reduces 51 millimeters or 2 inches on the inside of the curve, with 25 millimeters 1 inch over the outside of the curve. Two high-level platforms are provided with the inside area, the inside as well as the outside of the 2 degree curve of the broad gauge track with a super elevation of 100 millimeters, where the should be required extra clearance of these platforms both on the inside and the outside of the curve. B. Length of the buggy is 21,340 millimeters. The CC buggy distance is 14,785 millimeters. The height of the platform 840 millimeters. Radius of the curve is 1750 divided by the D equals 1750 by the 2% grade 875 meters. Extra clearance required on the inside of the curve. EC1 equals overthrow plus lean plus sway 51 millimeters. C2 squared over 8R plus EH over G plus 1 over 4 times EH divided by G minus 51 millimeters. Next example C is 14,875 millimeters. R is 875,000 millimeters. E is 100 millimeters. G is 1,676 millimeters. And H is 840 millimeters. For EC is equal to 14,785 squared over 8 times 875,000 plus 100 times 840 over 1,676 over plus fourth and 100 of the times 100 times 840 over 1,676 minus 51 millimeters. Extra clearance required outside of the curve End throw minus 25 millimeters equals L squared over minus C squared, over 8R with a minus 25, where L is 21,340 millimeters, C is 14,875 millimeters, R is 875,000 millimeters. Therefore, the E squared, EC 2 is equal to 21,340 squared minus 14,785 squared, divided by 8 times 875,000 minus 25 equaling 33.8325 millimeter minus 25 millimeters, 8.83 millimeters, approximately 10 millimeters. Therefore, extra clearance of the 45 millimeters should be provided with the outside of the platform, inner side of the curve of the 10 millimeters, inside platform, outside of the curve. 13.8. Widening of the gauge of the curve. The vehicle normally assumed with the center of the position straight flat track with the flange on the wheel with the stay with the clear the situation. However, the change of the curve track as soon as the vehicle moves onto the curve, the flange outside of the wheel leading the axle continues to travel in a straight line till it rubs up against the rail. Due to the coning of the wheel outside of the wheel travels a long distance compared with the inner wheel. However, it becomes impossible for the vehicle to hold since it rigidly with the wheelbase caught with the trailing axle to occupy a different position. In an effort to make the difference in the distance traveled by outer wheel and inner wheel inside the wheel slip backward and outwards wheels slip forward. The close study of the running vehicles of the curve indicates the wheels flange the ease of the passage of the vehicle road curves as is has an effect of increased gauge. The widening of the gauge of the curve, in fact, the same effect tends to decrease the wear and tear on both wheels and the track. The stipulations to lay down with regard to the gauge of the straight tracks curve of the Indian railways are given in table 13.7. The widening of the gauge can be calculated by using the following formula. Extra wide curve W is equal to 13 times B plus L squared over R. The B is the wheelbase of the vehicle. The R is the radius of the curve in the meters. L is equal to 2/10 of times H squared plus DH to the 1.5 power. Length of the flange meters and half the depth of the flange below the top of the root. D is the diameter of the wheel of the vehicle. Alright, 13.7, the gauge of the standard of the curve. The straight curve includes the curve of the 350 meter for the broad gauge, 290 for the meter gauge, and 400 and more for the narrow gauge. Gauge tolerance, negative 5 millimeters plus 3 millimeters. Gauge tolerance, meter gauge. Gauge tolerance for the meter gauge and narrow gauge. Meter gauge is negative 2 millimeters to 3 millimeters. Negative gauge, narrow gauge is negative 3 millimeters plus 3 millimeters. Alright, for curve with the gradient less than 350 millimeters, broad gauge 290 for meter gauge and 400 to 100 meters for the narrow gauge, up to 10 millimeters for the gauge clearance of the broad gauge, up to 10 millimeters for the gauge meter gauge and narrow. For the curve with the radius less than 100 meters for the narrow gauge, up to 15 millimeters for the meter and narrow gauge. Alright, 13, example 13.8. The wheel of the base of the vehicle moving the broad gauge of the track at 6 meters. The diameter of the wheel is 1,524 millimeters. Flange the protects the 32 millimeter below the top of the rail. Determine the extra width of the gauge required for the radius for the curve of 168 meters. This includes the extra width of the gauge actually provided with the Indian Railway standards. Lap of the flange, the L is equal to 2/10 of the square root of H2. H squared plus DH. The H is 3.2 centimeters depth of the flange below the top of the rail. D is 152.4 centimeters diameter of the wheel. Therefore, the length of the 2/10 of the square root of H, the depth of the flange below the top of the rail, plus the diameter of the wheel times the height and the depth of the flange of the top of the wheel, and you get 0.446 meters. Extra width of the gauge is 13 equals 13 times B plus L squared divided by R, or 32.1 millimeters. As per Indian Standard Railway trains, extra width of 5 millimeters provided with the curve of the radius less than 400 millimeters. Actual practice. Vertical curves, an angled form with the point of the two different gradients forming the summit with the sag explained with an angled form with the point of the contact gradient smooth and provided with the curve with the vertical curve, the vertical plane. Adams vertical curve vehicles are likely to have the rough run on the track because the side with the chain with the gradient may also be the bunching of the vehicle, sags, variation, tending of the couplings, and summits resulting in train parting and uncomfortable rides. To avoid these ill effects, the changing gradient smoothing of the provided with vertical curve, the rising gradient normally considered the positive and falling gradient is considered negative. Vertical curve is normally designed with a circular curve. The circular curve profile and ensure the uniform rate of the change of the gradients which control the rotational acceleration. 1318 shows the summit sags in vertical curve. This shows the rise and flag level fall that rise level. On the summits, rise less rise, fall steeper fall. Sags are the level rise to the fall level and fall, and the fall less in the fall, and then fall rise to the rise sleeper rise. 1391, calculating the length of the vertical curve, old method. Length of the vertical curve depends on algebraic difference between the gradient and the type of the curve formed, the rate of the change of the gradient, and in the case of Smith, it should not exceed 10th of a percent because of the 30.5 millimeters or 100-foot chords, where corresponding figure sags at 5/10 of a percent. Or 0.05% per 30.5 meters or 100-foot chord. Required length of vertical curve of achieving the maximum permissible is given in the formula. L is equal to A divided by R times 30.5 millimeters. The length of L is the length of the vertical curve. A is the percent of the algebraic difference between the sufficient gradients. R is the rate of change of the gradients, which is 1/10 of a percent of the sum of the curves and 0.05 of the sag curves. 3092, existing provision of the Indian Railway. It says, existing provision vertical curve is provided with the junction of the gradient for the algebraic difference between the gradients and is equal to more than 0.4% of the medium and radii vertical curves are gradient of 30.8. Broad gauge, you have A at 4,000 minimum meters, B 3,000 meters, C and D 2,500 meters, broad minimum vertical curve, broad gauge. Meter gauge, groups all routes, 2,500 meters, broad meter gauge. 1393, vertical setting of the vertical curve. Vertical curve can be used with various methods such as tangent correction and chord deflection. The tangent correction method, which is considered simpler, but the other methods are more convenient from the field staff described in Figure 1319 involve the following steps. The length of the vertical curve is first calculated, change the reduced level to RL, tangent points aspect of the worked out. Tangent corrections are computed with the help of the following equation: y is equal to c to x squared, and c is equal to g1 minus g2 divided by 4.n, where y is vertical ordinate, x is the horizontal distance for the spring of the point, g1 is the gradient number, the positive of the rising of the gradient, g2 is the gradient number, 2 negative of the falling gradient, and n is the number of chords upon the half of the length of the curve. The elevation of the of the curve to determine the algebraic adding the tangent correction of the OA. Example 13.9. Calculate the length of the vertical curve between the two gradients, meaning the sum of the one raised the rate 1 in 100, other falling rate is 1 in 200. The gradient rising track is 1 in 100 or 1% positive gradient, and the falling track is 1 in 200 or 0.5% of a percent, and negative changing gradient A is equal to 1 minus 0.5 equal to 1 plus 0.5% 0.5 of a percent equal plus positive 1.5%. Rate change gradient R, the summit curve is 1/10 of a percent. Legal vertical curve is 1.5 over 0.1 times AR times X A over R times 3.5 millimeters, or equal to 1.5 over 101 times 30.5. It's 457.5 meters. Alright, 1394, the new method of calculating length of the vertical. According to the new method, length of the vertical curve is calculated with the L equals R cubed. The length of the vertical curve, the radius of the vertical curve, the existing provisions, and the Q, the difference of the percentage gradients expressed in radians. It seems the length of the vertical curve calculated in new practice relative to some small compared with the length of the calculated using the old method. The length of the vertical curve according to the new practice considered very responsible for the purpose of laying in the curve field can be seen from the next solved example. Now, when the change of the gradient is performed, positive forms a summit, when the negative forms a sag. Raising gradient in 1 in 100, meet the falling grade of 1 in 200 on the group of the group A route. The inspection point changes to 1,000 millimeters, and it's RL 100 meters. Collect the length of the vertical curve of the RL and the change of the various points of in order to serve the vertical curve at location. First gradient 1 in 100, 1%. Second gradient 1 in 200, negative fifth percent. 0.5 of a percent difference of gradient is equal to 1 plus 0. Negative fifth or 1.5%. Length of the vertical curve L is equal to R cubed, 4,000 times 1.5 divided by 160 meters. Changing the point A is 1,000 minus 300, 970 meters. Change the point D, 100 plus 300 is 130 meters. R point A, 100 minus 30 times divided by 100 is 99.7. millimeters. RL at point B, 100 minus 330 divided by 200 is 99.85 meters. Increase the RL for 60 meters is 99.85 minus 99.7 is 0.15 meters. Increase the RL for 10 meters, 0.15 times 10 divided by 60 is 0.25 thousandths of a meter. First offset vertical curve x equals x times L minus x divided by 2R, where L is 60 meters, R is 4,000 meters, x is 10 meters. The calculation of RL of different points of the curve are shown in figure 13.9. Realignment of the curve. The rail curve is likely to disturb the original alignment of the patch of the time due to the following reasons. Imbalance loading both the inner and outer rail due to the excess with the slower speed with the cant deficiency, then higher speed instead of the equilibrium for which the cant has been provided. Effective large horizontal friction forces exert the rail passing train, but these forces tend to make the curve flatter in certain locations, sharper at the others. Radius of the curves vary from the place to place. The result in the rough ride of the curve due to the change of the radial acceleration place to place. Realignment of the curve therefore becomes necessary to restore the smoothing of the running of the verticals on the curve. 3.10.11. The criteria for the realignment of the curve. The Indian Railway Manual, the Indian Railway Works Manual, had earlier prescribed the curve should be realigned during the inspection running with the curve and found with the unsatisfactory. No hard fast rules was laid, and the curve should be realigned. Subsequently, the rail board prescribed the following criteria for the realignment of the curve: cumulative frequency degree. The group from group A and B routes, the need for the curve of realignment should be determined by the drawing cumulative frequency diagram shown with the variation of field varicine over the theoretical varicine. The varicine route variations measured at 20 meter chords should be limited to 4 millimeter, 55 millimeter group A and B lines respectively. Realignment should be taken with a cumulative percentage of versaline lines within the limits of less than 80. Station to station versaline difference. The type of the ride over the curve depends not only on the difference between the actual proposed varicine, but only on the station to station vericine with the actual vericine values. The station variation of varicine determines the rate of the change of the radial acceleration, which the comfort of the ride depends on the following stipulations has been made regarding the different gauges adopted by the Indian Railways. Broad gauge on curves where exceed the 1,000 kilometers an hour that permitted the station variation varicines are stationed at 10 millimeters apart should not exceed 15 millimeters instead of the 100 kilometers an hour. The variation should not exceed 20 millimeters or 20% of the edge of varicine, but the circular position whenever there's more. Meter gauge on curve which permit the speed of excess of 75 kilometers an hour. Station to station variation varicine station of 10 millimeters apart, but should not exceed 15 millimeters for the speed of 75 kilometers an hour. Such variations should not exceed 20 millimeters or 20% of the average varicine with the circular portion whenever the larger, whichever is more. Decision comparatively realign the curve, but there should be taken the exertion of the type of the ride with the curve to provide for the base for the cumulative frequency diagram. The distribution variation varicine between the station and described here. Curve realignment can be taken up with the following circumstances: unsatisfactory running of the track, other routes for curve of the alignment, but this should be taken with the curve of when a curve is found to be unsatisfactory. Result inspection due to the trolley foot plate with the locomotive of the rear carriage, or result various track tests that have been made with a carried out local adjustment. The abrupt variation of the varicines is about the adjacent station. The local adjustments and it should be done with the achieve the varicine variation within reasonable limits. Such correction should be carried out before complete curve realignment is taken. The string line method of realignment of the curve realignment existing of the theodolite and is difficult to laborious work. Therefore, the curve is realigned, measuring the varicines with the help of a string. The correcting with the varicine, the method of the known with the string lining with the method of the Indian Railways based on the following basic principles. Sum of all varicines equal the chord of the two curves between the same tangents are equal to the final value with the sum of the difference between the existing and proposed varicine, but 0. The throw of any station is equal to twice the second of the summation of the difference of the proposed existing varicine of the proper state of the previous station. Procedure: realignment of the curve using a string line method consists of the following three operations: surveying existing with the curve of the measuring the varicine's computation, sleuth, including provision of the proper transition, super elevation, revised alignment, swing of the curve, revised alignment, survey of the existing curves. Existing curves are surveyed as follows: the varicine readings are taken from the gauge phase for the outer rail with the curve at 10 millimeters intervals using 20-minute chords. Varicine readings are taken upheld with the nylon fish cord with the cord of the keeping the type prescribed reference difference. Distance 20 millimeters away from the gauge face at the side of the outer rail with the help of the special gadget. Varied readings should be taken with at least 6 stations beyond the apparent tangent point. Computation of slews. Slews are conducted with the valve length of the transition curve determined based on the permissible speed with the degree of the curvature per standard Pearson. Practice various Versand gradients range for the train Versine per unit of the calculated one for the length of the transition curve. The theoretical Versaline proposed to adopt the known. After calculating the Versaline gradient with the Versine proposed to adopt the transition length that can be computed. Therefore, the theoretical idea with the verse line with the proposed data of the transition line with the calculated either exactly detailed mathematical calculation, approximately geometrical method. The geometrical method of the verse lines are applied with the graph with the back of the nation, number of stations, and average figure of the verse lines is estimated with the drawing of the mean of the line in between the peak and the depressions graph on the figure 1320. Tabular statement is prepared in table 1310 with the stabilization number the existing with the verse lines. If they're given the column 1 and 2, the verse lines proposed adopted VP circular curve as well with the transition length with the calculated before the given column D. There should be ensured that the sum of the proposed existing verse lines are equal. Our figure 13 shows the graphic solution to find the average varicines, the varicines in millimeter station at 10 meters intervals, existing proposed varicines. Alright, verifying the differences between the existing and proposed verifying VP and VB minus VE for the calculated each station with the given in the column 6 shifting in the half of the station. First summation for the verifying the difference of the S times VP minus VE with the column 5. The between shifting is done between the half of the station and the nth row of the column the 5 plus the n plus 1 of the row of the column 4 plus n plus 1 of the row of the column 5, and this must be the 0 n. The second summation of the existing SSVP minus VE calculated adding the first summation verifying difference of the rate with the column 6 shutting the half of the station again, and it should be ensured for the second summation the difference of verifying which is equal to half the slew with the 0 that the first last station obligations if any of the conditions not satisfied correcting couplers are applied with the described next. 7. The correction couplers are applied with the column 7 change of the proposed varicine in such a way that it brings down the second summation of the difference of the varicine of one place, make the second summation negative in the other place, keeping the proper distance the correct number of the stations in between the first, second, and summation of the correcting the couples the SCC and the SSCC is given with the difference of the column 8 and 9 respectively, correcting the course applied with the depending on the value of the second summation of the varicine difference derived against the last station of the first final value. Adding the effect of the couple becomes 0. Similar, correcting the couples applied with the control of the slew obligatory points. The other two of the slews are limited to minimum possible view for the entire curve. The resistant half slews the column M6 and column plus column 9 of the full slews 2 times the columns of 10 that are shown in column 10 and 11. The final varicine of column 3 plus column C. Having to adopt the written column 12, the value can now be provided with the array of the introduction can't points with the 0 maximum can't are also counted in the shown figure shown in column 13. Alright, slewing curve of the new alignment. The following points should be kept in mind with the curve of the slew. With the new alignment, the positive slew indicates the inward slew. With the negative slew indicates the outward slew. The curve should be slewed with the accuracy of plus or minus 2 millimeters. After realignment, verifying the new curve should be measured with the uniformity. The necessary super elevation already determined should be given. The curve of the super elevation is 0 with the tangent point. With the curve that indicates the point should be a fixed and important location of the check, that be carried out during the maintenance if required using computers and calculations. With the normal method of the calculating slews and slow down tedious, the computerizing same would be all well appreciated. Eastern railways have been developed in 2. This shows the realignment curve based on the string line. Programs of the IBM 1401 computer reveal one of the calculating sleeve with the simple curve of the calculating the same with the compound curve of the obligatory position of the obligation station for the curve of realignment. The time taking the computing the realignment solution for the curve of the 150 station is about 1.5 minutes. Beside this, saving the time with the computerized calculation provides much precision. Alright, 310.3, curve correction and column recorders. The Indian has produced the 550 curve of the corrector for the continuous record of various curves that helping to improve the alignments. The utility of the equipment increasing can be used with the measuring gauge variation of the unevenness that is done easily making the suitable modifications to according to the research design and safety organization developing special attachments to be used with existing curve correctors, the recording unevenness gauge parameters, the converting of the existing curve corrector to the track recorder with the curve corrector, the new alignment, the measure of the following alignment over the 10 millimeter chord, the unevenness over the 10 meter chord, sleeper gauge variation. 13.10.4 realignment of the curves and double multiple lines. On double and multiple tracks, each of the curves should be string lined independently. No attempt should be made to realign the curve by slowing the uniform center to center distance from another realigned curve, doing the following reason. The existing track centers may not be uniform. Relatively small throw in one track may entirely entail a much larger, even prohibitive larger throw in an adjacent track. If necessary, if impossible to measure the center to center distance of the curved track along the true radial line, the small error of the angular direction measurement of the mean appreciable error of the true radial distance of the transition length of the entire entry and exit measured differently, which make it impractical to maintain uniform center of the even through degree of circular curves that is nearly the same. Alright, cutting of the rails of the curve. Running rails of the curves are usually laid with a square joint, the inner rail with gradually gained with laid over the outer rail of the curve track. The successful length of the D is inner the rail gains the outer rail with the length of the L with the circular curve that is calculated and follows. Difference in circumference outer rail and inner rail 2 times pi r minus 2 times pi r times r minus g equals 2 times pi g. Gain of length 2 times pi r equals 2 times pi g. Gain of length length L is equal to 2 times g 2 times pi g 2 minus 2 times r times L, which is gl times over r, equals DL over 1,000 for broad gauge and DL over 1,654 for meter gauge. The length of the outer of the rail, the circular curve of the rail, the radius outer of the rail, circular curve of the D is the curvature of the outer rail. G is the dynamic gauge plus the width of the rail head, which is 1,750 millimeters broad gauge and 1,508 millimeters meter gauge. Alright, figure 1324 shows the cutting of the rail curve of R and G and B, R and A, inner rail, outer rail. Normally, with the inner rail curve that leads to the outer rail with the amount with the half of the pitch of the first fish bolt. Inner rail is cut between an amount of equal to one full pitch, and another hole is drilled in between the fastening of the joint fish replaced. The number of the rails to be cut for a particular curve is worked out depending on the degree of length of the curve and pitch of the bolt holes. 1312, check of the rail of the curve. Check of the rails provided with a parallel inner rail of the sharp curve with the reduced lateral wear of the outer rail that will also prevent the outer wheel of the flange from mounting over the outer of the rail to decrease the change of the derailment vehicle. Check the rails are out of the quite the fastened since normally there has been worn out rails. Further, the wear is not considered questionable. According to stipulation presented with laydown with the Indian rails, check with the rails provided with the gauge face side and the inner rail of the curve sharper within the 8 degrees broad gauge, 10 degrees meter gauge, 14 degrees narrow gauge. Minimum clearance prescribed in the check rail of the 14.4 millimeters broad gauge meter gauge routes and 41 millimeters narrow gauge routes. Alright, 1322 show the check of the rails of the curve. Check of the rail, outer rail, inner rail gauge of 1,676 gauge. Summary: the design of horizontal vertical curves is extremely important with the rail with the tracks, both speed and safety of vehicles depending on the design, but the horizontal construction important to stipulations laid down with the Indian rails with respect to the design. Horizontal curves are highlighted in the chapter. The method of the calculating super elevation and length of the transition curves, the extra clearance of the horizontal curves are discussed. Alright, Chapter 4, Points and Crossings. Chapter 14, Points and Crossings.